Hi everyone, welcome to our CNI webinar from Fortress Power. My name is Kyle Bannon. I'm the CNI sales engineer for Fortress Power. I'm based out of Los Angeles, California. Thank you for your time today to get some info on our systems, our offering. We've got a lot of cool stuff to talk with you about today. First and foremost, we'll talk about who Fortress Power is, what we're about, how we came to be the company, the energy storage company that we are today. We will talk about our hardware options, but even before that, we're going to talk about the market, the CNI market, what that looks like in our eyes, and how we approach specifically these jobs within this power class. Then we're going to talk about the hardware. We're going to talk about our two commercial product offerings, the eSpire 280 and the eSpire Mini. If you're not familiar with them, we do have data sheets on our website if you'd like to check those out while we go over them. After we talk about the hardware, we're going to talk about the software side of our offering because we're more than just an energy storage provider, and I'll highlight that why we chose to go down that road in this webinar as well. And then finally, we'll talk about some of our modeling capabilities, what we can do to show you that these projects make both dollars and cents at the end of the day. So without further ado, I'm going to jump right into who we are at Fortress Power. If you do have any questions or would like to add your comments in the middle, I am going to wait till the end to answer all the questions. And if we don't get to your questions due to time or we don't have the answer up front, we'll respond to you privately after this webinar. So please use the chat function and go to webinar, the questions function to ask any questions that you off the top of your head in the middle of this call. And at the end of this presentation, I'll go back and I'll read some of those questions and answer them appropriately. So let's dive right in here. So a little bit about Fortress Power, who we are, what we're about. We are a lithium iron phosphate, that LFP energy storage company for both residential and commercial applications. So you can see on the screen there, 5 kilowatt hours up to 4.2 megawatt hours. We're going to be focusing on the higher end of that scale today, but we really cut our teeth as a residential company here at Fortress. And so we've got a huge following in the Caribbean and really all over the United States, North America, South America, for being able to provide high quality products, both residentially and commercially. We are headquartered right outside of Philadelphia in Langhorne, Pennsylvania, about 45 minutes north of Philadelphia. But we do have branch offices all over the world, really. I'm in the California office here in Los Angeles. But we've got an office in China and an office in Puerto Rico, in addition to our headquarters in Philadelphia. We were founded in 2017, which in battery years, that's just 6 years ago, but in battery years, it might as well be 15, 20 years. We've seen and done a whole lot in that space. It's a very dynamic industry, and especially in energy storage, with electrification and all the incentives that are now become available for energy storage. We've done and seen a whole lot, like I said. So 6 years might as well be about 20 years of experience in this space. Something really cool about Fortress is we are backed up by a private equity firm out of Houston, Texas called White Deer Energy. What's really cool about that is they are minority owners of Fortress Power. So we kind of control our own destiny here at Fortress. We're owned by solar veterans who have been in the space for combined, 40, 50, 60 years of experience in solar and energy storage. So that's allowed us to expand greatly. We've doubled or tripled our headcount in the last 2 to 3 years, with plans to expand even more with our offices across the world. In terms of installs, we've got 30,000 plus installs all over the world, be it United States and the Caribbean, South America. And we work with numerous government institutions, municipalities. We've worked with them and we continue to work with them because they recognize the high quality product and high quality support that we can bring to these energy storage projects. So just to name a couple of the companies that we have worked with and continue to work with, down in Puerto Rico, there's the Housing Authority, Puerto Rico Department of Housing. We're doing some low-income housing projects that are all including Fortress Power batteries. Of the 9 contractors that are working on that project, I think 8 of them are using Fortress Power for their energy storage. So it's over 5,000 homes that are using Fortress Power residential products in their offering. But we've done everything from banks. We worked up in Hydro-Quebec, who has their own energy storage arm. We've helped supplant that energy storage product that they offer with our own product because they see the value, see the quality of our product. The first job we ever did actually was a commercial product. Like I said, we cut our teeth on the residential side, but the first one we ever did was for SEPTA, That's Southeastern Pennsylvania Transit Authority. That stands for that they run the subway system and trains in and out of Philadelphia. So we did backup power for some of their switching gear stations. And like I said, we continue to work with SEPTA today, working on large scale commercial products. But we also do fully off grid projects, right? We worked 200 plus homes for the Navajo Tribal Authority out in New Mexico. So this just goes to show just some of the companies that we work with, not at all inclusive of everyone that we do work with, but we're here to provide those high quality products, high quality support, and these are just testaments of some of the companies that we do and still continue to work with. Now, that's who we are, right? LFP energy storage from 5 kilowatt hours up to 4.2 megawatt hours. Now I want to talk about the market that we're looking to sell into, right? So the way that we see it, there's a hole in the market, right above residential, right below utility scale. Call it 200 kilowatt hours to 5 megawatt hours of storage, where there are a ton of applications, and just some of them are listed below, right? You got fully off grid, peak shaving, time of use / arbitrage, grid tied backup for places like agricultural facilities with really high demand charges, community solar, and grocery stores, anyone that can justify resiliency, right? Having backup power in a grid outage. The issue is with this green bubble is there are not a lot of products on the market that can adequately fill that space in that power class. Now, why do we think that is? The reality is that the companies that can do those products, say 500 kilowatt hour, 1 megawatt hour, even 2 megawatt hour, they would rather be doing 5, 10, 20 megawatt hours worth of energy storage, because the reality is the engineering problem is very similar despite the size. You're going to spend the same amount of resources and time engineering wise to execute a project in that green bubble as you would in the red bubble, and you're ultimately going to make a lot more in margins doing those larger C&I utility jobs. So we've gotten feedback that the companies that can do these jobs in the green bubble, right, 500 kilowatt hours, a megawatt hour, they don't have time for it. They would rather focus their efforts on the larger projects that were going to make them more money. Now, that's not great. Nobody likes feeling blown off, especially for someone else like that. So, and on the residential side, right? Yes, technically you can stack 48 volt batteries to get to say 350 kilowatt hours of energy storage. Our eVault Max can be scaled up to 20 some eVault Maxes can get you there. But at a certain point, it doesn't make as much sense to use all these 48 volt inverters, 48 volt batteries. There's just a lot of wiring. It's complex. You have multiple companies that are involved, battery, inverter, maybe microgrid controller. It just gets a little bit hairy. So why not just get one big product at a certain point to satisfy the needs in that power class? So that's kind of how we see the opportunity. That's how we're approaching these projects, is we want to be that gap between utility and residential scale with something that's medium size, right? Not like a 20-foot shipping container that you need a ton of footprint for, because they have their space. The utility projects typically use those type of products. Modularity, we want something that is scalable. So think Lego building blocks that we can scale up and scale down based on your application and your budget. And last but not least, we want something that's as plug and play as possible, right? You want something that you can just put on a concrete pad, hook up the connections and turn it on, and it's gonna work, right? So that is what we're trying to be for this green bubble. Not necessarily utility scale. We have our residential market. For C&I, this 200 kilowatt hours, 5 megawatt hours, this is what we're trying to be. So that's kind of how we see the market. I want to briefly talk about how we approach these projects just one-on-one, right? When someone comes to us with, saying, I need an energy storage system, this is how we approach it. We don't want to be just a battery manufacturer, right? There are plenty of people who will sell you a battery and say, figure it out. You got to figure out the bidirectional inverter. You got to figure out the balance of system, right? Like grid sensing relays and islanding equipment to make sure that it can work in a grid tied backup system. Or they'll say, okay, here's all the hardware, but the software, microgrid controller, energy management system, not our bag. You got to go do a third party for that. What we're trying to be in this space is truly vertically integrated hardware, software, engineering support from pre-system design all the way through fleet management and O&M. Think of this green circle as a menu, right? We can take as much of this off your plate on the battery side as you'll allow us to, whether it's from the top system design, financial modeling, energy tool-based style, pro formas and payback period analysis, again, all in-house to Fortress Power. We're not outside or sourcing this or using other software to do it. The same software that we're using to model is the same software that's going to be running the controller in the field. Selecting products outside of our energy storage system that we know you're going to need to accomplish the goals of the product, but it might not be from us. We have a list of equipment that, PV inverters, gen sets, things that we've worked with in the past that we know talk nicely with our equipment, and we can say, yep, select that PV inverter for this application because we know it has all the capabilities that you need. On-site commissioning support, right? We can send an engineer to site to oversee that installation process and then perform the startup and commissioning. So we know that the system is going to perform on site just like we sold it, just as we expected, right? The whole thing here is no surprises, no mismatched expectations. And then finally, fleet management, O&M support. I'll show you guys in a bit what it looks like, the online dashboard for remote monitoring and setting this customizable alarms. But it's that, like I said, that hardware mixed with the software, mixed with the O&M and fleet management support, really is the full suite of things you need to accomplish for these microgrid systems. So we like to say one hand to shake, right? You don't like going to 3 or 4 other companies, a battery company, an inverter company, a controls company. Just come to Fortress Power. We'll talk you through what you need, and we'll be able to support you, like I said, from pre-design all the way through commissioning. So that's, like I said, we've talked about who we are at Fortress. We talked about how we approach the market. Now let's get into the nitty gritty, what we actually sell here at Fortress. Let's talk about the hardware. So this first product we're going to talk about is called the eSpire 280. It stands for 280 kilowatt hours of energy storage. It's essentially these 3 pieces of equipment, right? You got a 280 kilowatt hour battery cabinet in the center. On the right-hand side, that's a 125 kW 480 volt inverter. And then on the left-hand side, that's really our special sauce. That's the microgrid control cabinet. And that's really the brains of the system, right? That's handling the system level BMS. That's making sure the power is going, to the battery or to the loads or to the grid as appropriate. So this is, when you think eSpire 280, think of these 3 boxes, right? In terms of scalability, you can see the first bullet point there, 280 kilowatt hours up to 4.2 megawatt hours. So the way that works is we can put 5 of those 125 kW inverters together to get to 625 kW of 480 volt power. And we could put 3 battery cabinets to each one of those 5 inverters. So that's a total of 15 battery cabinets in a max configuration. So 15 times 280 kilowatt hours, roughly 4.2 megawatt hours of energy storage. To give you an idea of what that looks like, right, in the picture in the top right, that's 6 battery cabinets on a concrete pad. Roughly 1.7, 1.8 megawatt hours of energy storage there. And in terms of modularity and flexibility on site, that's what I meant when I said earlier, we don't want like a 20-foot shipping container that you have to have a bunch of footprint. We want something that's a little more flexible. You get a concrete pad similar to a gen set. You don't have to necessarily have the inverters right next to the batteries. We can wrap these things around buildings if we have the space for it. As long as it's per the code, we can make it work. So that's what we're going for, right? This is not a shipping container. It's a little more flexible, modular design. So some things to note about this energy storage system. Not to mention it is a CATL prismatic LFP cell, right? EV grade cells. There's all sorts of grades of battery cells. This is the highest grade for the highest demand market. We're actually selling that into the energy storage market. So on top of that, it is a liquid cooled battery. So that is really the future, in our opinion, of battery storage is having a liquid cooled system, because that liquid cooled system ultimately extends the lifespan of your system, right? It's 3 times more effective at just fans, HVAC fans, just blowing air on the module as the battery. The liquid cooling system's fully integrated, right? There's no external water lines or anything you need to hook up. It's kind of like a gaming PC or like a car radiator. It removes that. It's very close to the cells of the battery, and it can remove that heat very effectively. So that liquid cooling system is, again, integral to this system and extending the lifespan of your system. Speaking of lifespan warranty, this has a standard 10-year warranty on the system, and we can extend that up to 20 years, though I will be frank with you all, any battery company who's offering a 20-year warranty for their energy storage system at this point in time is just baking in replacing the equipment at some point between year 10 and year 20. So we do something similar. We do offer that extended warranty, but no, the standard warranty for this is 10 years. And depending on how you cycle it, right, you can expect this to last longer than 10 years, kind of like a truck, a Toyota truck, right? If you service this thing properly, keep everything happy as far as the cells go, you can expect this thing to last at least 10 years, right? I talked about microgrid controls. Now, this thing comes with our in-house microgrid controller and EMS software system that runs the controller. That's not typical, like I said, of all energy storage systems. A lot of energy storage systems will Spirit Airlines you, right? They'll say, okay, yeah, here's the battery, but microgrid controller, nope, that's an add-on. That's an add-on. It's not us. You gotta add that. So just know that our microgrid controller comes embedded every single system, every single eSpire 280 and eSpire Mini, which we'll talk about in a sec, and any sort of application that you can think of for the system, right? So fully off-grid microgrids, grid-tied backup, peak shaving for demand charge management. It can also do demand response and virtual power plant out of the box. It's OpenADR 2.0 compliant. It's ready to go. Depending on what application that you want to use this battery for, we have different equipment selections, different software selections, but just know that anything that a microgrid is capable of, and I know that's a vague term, but anything a microgrid can do, this microgrid system can manage. And that going to that last point there, the fleet management and remote O&M, you can see from a 30,000 foot view just how all your systems are operating, right? Are there alarms on any of the equipment? Not just our equipment, right? But stuff that's talking with our equipment, like PV inverters, like relays. So I'll show you guys what that screen looks like in a minute, but that goes hand in hand with our microgrid controller and EMS system to give you insight into the system instead of having to go out and punch an HMI and get a bunch of info that way. Just to show you a super rudimentary line diagram for this system, we do have a more technical example that I can distribute after this call, but this is in general how we're AC coupling the system. And that's a good thing to note. This system is going to be only AC coupled for now. I think there's some development down the line for potentially DC coupling these with a DC to DC charge controller, but for now, the eSpire 280 is going to be AC coupled only. So you can see the power conditioning system AC coupled to say 600, 800 amp panel. The size doesn't necessarily matter. It really matters just so how we size contactors for islanding if we need be. But you can see the PV inverter up top. That's not in our scope, but like I said, that green line connecting to the microgrid controller, that's what we're helping you select the equipment for. We know that that green line is going to be uninterrupted. We can send and receive Modbus signals from the PV inverter to our controller and vice versa, right? So if there's an example, say we're in a fully off-grid system, right, and the battery is fully charged, the loads, there's not enough load to offset the demand or the power being output from the PV inverter. We'll send a signal to the PV inverter to curtail the solar if need be, right? They're just some of the functions that can happen via that Modbus. But like I said, I'll send out a more technical line diagram. This is just how we are AC coupling this eSpire 280 system. Now, I want to show you guys a project that we installed up in Northern California. This is in Eureka, California. And just a quick note, this shows a 125 kW 233 kilowatt hour system. Long story short, with the UL 1741 SA and SB requirements coming down in California, we had to upgrade our inverter to be SB compliant. And as a result, to match that new voltage range for that new inverter, we needed to add a battery module to our eSpire 233 system to make it the eSpire 280 system. So just keep that in mind. This is kind of an older iteration of the eSpire, but still the same cabinet, just adding an additional battery module with an upgraded inverter and some consolidated equipment. For example, that white box that we previously called our auxiliary control cabinet, we've been able to consolidate that equipment into that far right cabinet, the microgrid control cabinet on the pad there. So just wanted to make that clear first, but to give you an idea of what this system is doing, right? Why are we adding a battery system here? They're in PG&E territory, this school district up in PG&E. So first and foremost, they said we got to keep the power on when the lights, or we got to keep the lights on when the kids are in school, right? So backup power was their #1 play for this system. But in addition to that, you can see at the bottom, they were also adding a relatively small level 3 EV charging station for electric bus. So they realized, hey, our power demands are going to be much more than they were before. It's going to affect our power bill. We need a way to mitigate this demand, especially if down the line they go to add even more level 3 chargers. So the dual use here of backup power plus peak shaving, by far being able to stack that value is the best way to help these systems pencil. And in this case, it made great sense for backup power and peak shaving. Now, one thing that this system is future-proofed for, right, that wasn't necessarily ready when we installed on site is virtual power plant, right? All the utilities across the country really are starting to roll out these virtual power plant programs. especially in places like Texas where the market isn't as regulated, but even in California, PG&E, SC&E, they're all coming up with these virtual power plant demand response programs. So this system fully capable of those programs once they're rolled out. So I can imagine they're going to take advantage of that additional value stack once the time is appropriate. So keep that in mind when you're thinking about these systems. Just, oh, I need backup power, great, but think about all the different ways you really could use this system to generate value for your customer. Just keep that in mind. Try and stack that value whenever you can. So that is our larger system. That's the eSpire 280. That's the larger side of that green bubble, right? On the smaller side, kind of the niche within the niche, we have our eSpire Mini product. Now, this was just announced this year in February, so it's been on the market for about 6 months. We officially started delivering these systems in around June, July. So some things, major differences between the eSpire 280 and this system. Where the 280 starts at 280 kilowatt hours, this system is going to start at 81 kilowatt hours. Where the eSpire 280 starts at 125 kW of 480 volt power, this system starts at 30 kW of either 208 or 480 volt and can go up to 90 kW of 208 or 480 volt. Now, you will need an external transformer for the 60 kW and 90 kW units to step down to 208, but we'll talk about that in a sec when I show you the internals of the unit. This system is capable, it's the same exact microgrid controller, same exact software that the larger system uses. So anything that you can think of in terms of microgrid control applications, this system is fully capable of. One thing that's probably obvious to note, right, is this is just one box versus the eSpire's 3 boxes. And that's, we were, again, able to consolidate a lot of this equipment into one smaller footprint. And it's not a megawatt hour solution. This is really focused on, like I said, from 81 kilowatt hours up to 266 kilowatt hours in a single cabinet. Now, we can parallel these cabinets together, right? We can parallel up to 3 of them together. So technically we can get up near, 800 some kilowatt hours and up near, what is that, 270 kW of power output. But at a certain point, it's the same overlap with the residential systems. At a certain point, it just makes sense to get one large eSpire 280 versus stacking these mini systems. But the reality is we have options, right? We like options that overlap because depending on the priorities of the project, priorities of the site, we can recommend one equipment or another. And that goes to my next point. This system can be AC or DC coupled, right? So we have DC to DC charge controller units inside this box, and I'll show you what that looks like in a sec. But this can DC couple up to 135 kW of DC power directly into this unit. So what's great about that is you can eliminate your PV inverters, right? That's extra equipment, potentially lead times. I've seen some lead times for PV inverters off the map. I think it's gotten a little better recently, but just know that you can eliminate that PV inverter if you can DC couple this system. We talked about scalability, and as far as where you can put this is good for indoor or outdoor installations. Just gotta maintain to the code essentially, right? So 3 feet in front of the battery cabinet. There's some ventilation requirements as you see, but the last major difference that I want to note about the system is while the eSpire 280 is liquid cooled, this one is HVAC cooled, right? It's just an air conditioning unit that you can see on the left side of the cabinet there. So it is more cost effective than that very complicated liquid cooled system. This is essentially if you want a microgrid, but you don't want to spend Ferrari microgrid money. This is a little bit more cost effective for what you're trying to accomplish in the microgrid space. So just showing what this thing actually looks like on the inside. On the left side there, that's where all the battery modules are going to go, right? And it is modular in that 81 kilowatt hours or 266 kilowatt hours, and we have some steps in between there. We're just sliding in battery modules to get you to that capacity that you need. Same thing with the inverter power up in the top right. The number 2 shows 30 kW bidirectional inverter segments that we can do 30, 60, or 90 kW of output power. So like I mentioned, the 30 kW output unit, that can output natively at 3-phase 208. You don't need an external transformer to step down or an isolation transformer to go from delta to Y. The 30 kW unit, just one inverter, can handle 3-phase 208. Now, the 60 kW and 90 kW units, we're working on that to get, we're in development to get a transformer internal to this unit so that can also output at 3-phase 208. But keep in mind for right now, the 60 kW unit and the 90 kW unit are going to output at 480 volt Y orientation. So in order to get to 3-phase 208, you would just need an external step down transformer and that wouldn't be part of our scope. So that'd be something that the customer would have to handle. In terms of DC coupling, right below those inverter segments, so those 45 kW DC to DC modules, so they can each take 45 kW, right? So 45, 90, or 135, depending on how much solar you have. And then in addition to this, there's also an ATS in this unit, right, to handle the grid following to grid forming switching. It's about a 30 millisecond transfer time. So while it's not a UPS system, right, it's not good for critical data center operations or like hospital equipment that can't, has to have less than a cycle or a cycle and a half of downtime. This does have relatively quick switching, 30 milliseconds. Now, we can make recommendations. Say you do need it for a critical application, we would look to pair it with a UPS that are relatively cheap, right? That can handle, say, the first 5 to 10 minutes of that critical outage, just in time for the battery system to switch over and form the grid. But that's typical, again, like of these very critical situations. So if you have questions about that, just let us know. But ultimately, that's what we would recommend in that situation. Like I said, this has the same exact microgrid controller and the same software that we'd be using for the larger system. So now I want to show you kind of what that looks like. But actually first, I want to show you, that was just a rendering, right? This is an actual picture in our lab of a fully loaded unit, right? So this would be 266 kilowatt hours. This would be up to 90 kW of inverter power, up to 135 kW of DC coupled solar. It also has a UPS in the unit to handle black start capabilities. And all the breakers, load side, grid side, inverter side that you would need to make this system operate. Now, I just want to talk about what makes a project quote unquote e-spirable, right? There's, like I mentioned, there's overlap. But when I first sit down to look at what system makes the most sense for the customer, I start with voltage, right? Okay, if it's 480 volt system, we want to avoid adding extra transformers when necessary. Because it, like I said, adds lead time, adds installation, adds cost in the form of equipment. So voltage first and foremost is what I'm looking to match with these energy storage systems. Next would be power demands, right? But take a step back, let's go back to voltage. Obviously the eSpire 280 is 480 volt output only. You can still operate it with 208 volt systems. If you need more than say 90 kW of power demand, there's nothing stopping you from getting an external transformer and stepping down the system. But because the eSpire Mini can output at 480 volt or 208, that when we seek 208 systems, we typically lean towards the eSpire Mini if we can accomplish it with the 30 kW system. And then on the right-hand side, that's our eVault Max. That's an 18.5 kilowatt hour battery that is really our residential flagship product. So when you get into single phase 120, 208 systems, single phase, split phase, that's definitely the product that we'd recommend, ultimately because you would need a transformer to step it down and just handle one of the legs from that 3-phase system. So just these 3 products cover the gambit of all the different applications for energy storage that we see. And depending on, again, the voltage, now we talk about power demands. The power demand of the eSpire 280 starts at 125 kW for that bidirectional inverter. So really between 90 kW and 125 kW, the eSpire Mini can't really handle it in just one box, right? So you'll need a 125 kW if it's greater than 90 kW of power demands. Demands between 30 kW and 90 kW, I think that's pretty self-explanatory for the eSpire Mini because we have those 3 inverter segments. And for the eVault Max, demands of less than 50 kW, I base that really on how many 48 volt inverters do we need to wire up to make this thing make sense. You can definitely do 48 volt systems higher than 50 kW demand. I wouldn't recommend it. You can make it work, but it gets very complicated. You really need to know what you're doing. So again, why not just get one big turnkey system that works out of the box? In terms of capacity, right? 280 kilowatt hours is the larger system. So I picked right around 200 kilowatt hours. That's where I think the trade-off starts to happen in terms of budget, in terms of complexity. So if you're looking greater than 200 kilowatt hours, obviously we have the eSpire Mini can go up to 266 kilowatt hours. So there's overlap in that. Okay, do you want one footprint? Do you have space for 3 boxes? There are considerations that we can talk through that one of these systems is going to make sense depending on which capacity you need. And then you see there, the eVault Max, like I said before, we can stack 20 of those up to get to 370, 380 kilowatt hours. But at a certain point, just get one system and it just makes a whole lot more sense. Unless we go to our last point, we talk about budget. And this is where, again, all these overlaps happen depending on, the value that you see in complexity and reducing complexity, or having it all in one box from one company. We can decide which system is going to make the most sense. Generally, eSpire 280 is going to be above $200,000, just rough numbers, right? eSpire Mini, you're looking between 100,000 and 200,000 for a budget, and for the eVault Max, you can put a system together really for less than $100,000. So these are all the things that go through my mind when I help you guys select what energy storage system makes the most sense. So keep this in mind when you see projects come across your desk and how the conversation is going to go with us. And I'll talk in a minute about how we go about those conversations. Right, we have a checklist that you fill out to give us more information about the project. But like I said, we'll get into that in just a sec. So that is the hardware side. Talked about who we are, talked about the market, talked about our hardware options, eSpire 280 and eSpire Mini. Now I want to talk about our software, our microcontroller and software. And just a bit of background, right? When we first went to market with our commercial storage systems about 2 years ago, we were doing what most energy storage companies were doing, is in saying, hey, you got to get a third party. We're not a microgrid control company. The software is what makes these things run, but we have the hardware that's definitely gonna work. What we realized very quickly is, not everything coming from one company under one umbrella adds some frustration in the form of you get finger pointing if something goes wrong. You're dealing with multiple companies. You have multiple softwares interacting with each other. You don't know if it's gonna work together nicely out of the box. So what we did is we said, okay, we need to pair this with our own microgrid controller. We actually went out and bought a microgrid controls company from a company called CleanSpark, publicly traded company. They do a lot of Bitcoin mining. Energy efficient Bitcoin mining is their game. And last year, if you may not have noticed, Bitcoin kind of took a dive, and they were in a position that they wanted to sell off their microgrid control arm. So we were in a great spot as a company that we were able to purchase that whole business unit from CleanSpark. And what that came with, right, is obviously the hardware and software that runs the system. But in addition to that, it came with their entire team, who has been working on microgrid control systems for 8+ years. Right there, this microgrid controller has been used in DoD applications, like Camp Pendleton down in Southern California uses this system. It's also used in places like golf courses. Rams Hill Golf Course in Southern California uses this microgrid controller. So we felt very comfortable knowing that this system has been in operation with other energy storage systems, other PV inverters, and just integrating that into our umbrella offering so that we know, again, everything is going to work out of the box, that you can do anything a microgrid controller can do, right? So whether that's reporting or O&M, like I said, I'm going to show you a couple screens on what that actually looks like when you get into the software side of the system. So this first screen that I'm showing is called our power flow screen, and there's a demo of all of this that's much more dynamic that we can distribute after this call as well. But this is just showing a static screen of what this power flow screen looks like, right? It shows what's my load consuming, what's my state of charge for the battery, how much grid power am I pulling, what's the solar generating. This is really good snapshot view for any higher ups in the company that just want to say, hey, I paid a bunch for this system, how's it working, right? And you can see that month-to-date savings. The way we're able to generate that is when we go to commission, even pre-commission these systems to get all the data ready. We say, okay, give us your rate structure that you're going to be paying for your system. And what we'll do is our model will run and say, okay, without adding a battery, this is what you would be paying for power. Now that you are adding a battery system, this is how much you're saving as a result. So that information, like I said, at a glance, at a snapshot, can give your customer the warm and fuzzies that, hey, the system that I spent a lot of money engineering and installing is working like I said it would, right? Another great screen that we have is called our adaptive analysis screen. And what you're seeing right now is essentially the load profile on the facility, right? So that black line is how that facility is using power throughout the day. What's underneath it is the mix of energy that we use to fill up that load, essentially, right? So red is grid use, yellow would be solar power, green would be battery power, black above the curve, that's actually charging the battery from the solar, and then purple would be sell back to the grid. That's that negative number below the line there. this, like I said, gives you a great idea at any given point in time how your microgrid is operating. So, for example, say you have an agricultural facility that they run, this really, really high power equipment from 9 a.m. to 12 p.m. every single day. Well, you would see a huge spike in the load profile from 9 to 12. And then maintenance manager could go back and say, well, I know we use this equipment. How is my microgrid system handling it during this time? They can go back and say, oh, well, here's the power mix for these 3 hours. And really what it does is allows you to make better decisions on how you operate your business, right? If you can squeeze even a little bit more value out of your system based on how you use the power in your facility, that it's all gravy, it's all money in your pocket, right? So being able to help make those decisions by having these visual cues to do that, I think goes a long way in helping you see the value in your system. Now, last but not least, on the EMS side, I'd mentioned the fleet management screen, right? That 30,000 foot view. We can do all these customizable alarms. Again, not for just our equipment, but anything with the Modbus map communicating with our microgrid controller. We can send text messages, email alerts to maintenance personnel. We can have different credentialed views. We'll have an insight into this, so there's no more picking up the phone and saying, "Oh, my battery's not operating. I don't know what's going on. These lights are." Nope, don't worry about it. We already have seen it. We can even be preemptive about it and let you know that something may be off kilter. But again, you can manage as many sites as you want with this. This is that perfect 30,000 foot view to see across your portfolio how these systems are operating. And if your customer doesn't want to go to a bunch of different online dashboards for this to see how all their systems are operating, we can integrate into building management systems, into their own fleet management portal via API. We're open to discussing that. It's full. This system is fully capable of doing that. So that's in a nutshell how the software really adds value to these microgrid applications, right? Like I mentioned, the big thing is you don't want any finger pointing. You don't want any consternation or frustration when something does go wrong or you need to see into the system. Being able to go to one company, right, one hand to shake, makes it so much easier and takes a lot of stress off of your plate and off of the customer's plate. But now I want to talk about our modeling capabilities, right? This is actually the last thing I'm gonna talk about in this webinar. So when we purchased that microgrid control team, the hardware, the software, the team, it came with their modeling capabilities that they had built in-house, and that their modeling is called MVSO, right? And it's our modeling, right? Microgrid value stream optimization. And it is exactly what you think it is. It's like Energy Toolbase. You send us 15-minute interval data, you send us your rate structure, and we can optimize the battery size, we can optimize the solar size, we can tell you what your payback period and rate of return is going to be for the different optimizations. And then ultimately, it really allows you to make a better decision before you even put any money down how the system is going to operate. Because at the end of the day, if the vast majority of these systems, right, if I had to put a number to it, 3 out of 10 customers, I would say, are solely focused on resiliency, right? Where they are in a location where rate structure doesn't matter. They're in a place where they don't necessarily have the opportunity to make money on a virtual power plant system, but they only care about resiliency. 7 out of 10, the project needs to pencil for it to make any sense, right? So we can take into account IRA incentives, ITC, SCHIP, you name it. We can build in the tax incentives to show you both pre-tax and post-tax what the payback's going to be, what the rate of return is going to be, and ultimately help you and the customer make a decision whether this is worth doing, right? So that, just like I showed you on that power flow screen, it'll run the model that says, okay, without a battery, this is what you're going to be producing in terms of power. This is what your power bills are going to be. After adding a battery, these are how we're going to be able to shave the peaks. This is how much money you're going to save annually as a result of this system. So I will say each job is its own kind of puzzle. I say it all the time, and some of the familiar names on this list will probably have heard me said this before. But if you've done one microgrid, you've done one microgrid. They are all going to be custom made. They're all going to be their own puzzle, like I said. So there are no real rules of thumb for what systems are going to make sense. When you're talking about demand charges, that's probably the only rule of thumb I have is if it's above $15 to $20 per kilowatt for demand charges alone, you may be able to get some money there as a result of shaving those peaks. Above $20, we definitely need to talk about using the system for demand charge management. But it really needs to be a perfect storm in terms of how you use your power, right? Really spiky load profiles as opposed to static, like plateauing load profiles work best. And again, those demand charges, it really is a factor of how those two work together to make a battery system make sense. So, but that's what the model's here for, right? Backup systems are relatively easy for us to size. We say, what's your critical load and how long do you need to run it for? That's relatively simple, right? There's some other factors there, but in a nutshell, that's what we do. For these money-making opportunities, right? If we need to get a payback period analysis, we do need load profile data. We need some more information than we would otherwise to size for a backup system. So we can talk about that in just a sec, what that would entail. But that's really what we're about on the CNI side, right? We talked about Fortress, we talked about our hardware, talked about our software, talked about the modeling capabilities, and we talked about this menu, right? We want to be your partner for these energy storage systems. We want to be more than just a vendor, more than just a manufacturer. We have the engineering support. We have EEs on staff that while we won't sign off on drawings, we're making recommendations and marking up line diagrams for you to get you a custom tailor-made microgrid, right? So I hope that we can be of service for you in this green circle. But at the end of the day, it's a very consultative approach, right? I'm not going to sell you something that doesn't make sense. And more than anything, I want customers to be educated on what's out there and what these systems are really used for. So with that being said, I'm going to hop into the questions segment. Let me see here. Alrighty. And if you do have any additional questions, please throw them in the chat now. Okay. Is Fortress both a battery OEM and also provides EPC? We are not an EPC, right? We work very closely with EPC partners, and we're actually building that partner base across the country. We've got pockets that we have really trusted partners in terms of EPCs, but we are just an OEM at the end of the day. We want to be a little bit more than that, but we still fall under that OEM category. Let's see what else we have here. Roughly how much is your system? The three size budget ranges seem to show $1,000 per kilowatt hour, but the last time I asked was 12 months ago. I think it was $850 per kilowatt hour for equipment only. So the budget ranges that you saw were accurate, right? But I would ask that you keep in mind this is boiling things down to a price per kilowatt hour is tough when you're providing more than just the battery, right? So think about the value that you get in adding the microgrid controller, which alone can cost $50,000 to $100,000 plus a subscription fee to run the software, right? So I think if I had to put just the equipment cost to a price per kilowatt hour, it'd probably be closer to $600 or $700. But the fact that we're adding all this additional equipment to make it a one turnkey system from one company does skew that price per kilowatt hour up a bit. So I would challenge you to think a little bit differently about how that price per kilowatt hour works out and what exactly you're getting for the value of your system. Alrighty. Okay. I think that's all the questions that I see for now. Again, if you do have more questions, please send them to sales@fortresspower.com or my email address, which I'll give you here. It's Kyle B as in boy, @fortresspower.com. Feel free to reach out to me directly, and we can discuss any other questions that you do have. I think with that, I'm going to wrap it up. Thank you guys very much for coming to this webinar. I appreciate your time today. It was hopefully as fun for you as it was fun for me. I really do enjoy educating people on these. And I hope that you gain something out of this. So thank you again, and I hope everyone has a great day.